Good morning and welcome to A4, Example 1. Whether you fully understand it or not yet, you have to realize that dividing polynomials can be done exactly like real numbers. And we can use the long division algorithm, which you guys have learned in elementary and middle school, and we can apply to the problem here, which asks us to divide one polynomial by another. So, our long division steps are divide, multiply, subtract, bring down, repeat. We can do that for 1,573 divided by 13. And we don't divide the whole number, right? We break it into parts. So we divide the first part by 13 and we get 1. And then we multiply 13 times 1. And then we subtract. And then we bring down. And we repeat the process. Multiply, subtract, bring down, divide, multiply, subtract, and we're left with no remainder. And we see that if we divide this, we get 121. And so you're going to hopefully see a lot of similarities in this process between dividing this number, right, 1,573 divided by 13. So let's get started. And we take a look at the problem. Now, we're going to begin by dividing. Just like we divided by just 15, we're going to take x, and we're going to take x plus 3. We're going to just take the first terms. And so we're going to divide just the first terms. And so over here, you can see that being done. And so the term with the highest degree divided by the term with the highest degree. So what is the term with the highest degree? X plus 3, or sorry, not x to the third divided by x. X to the third divided by x is what we have. And we get x squared. And so that's what we write. And notice where I write it. I write it the same way I wrote it over here. I wrote it on the last digit that I divided by, or that I divided into, and I do it the same thing here. Now the next step in long division is multiplication. It says divide and then multiply. And so what are we going to multiply? Well, we multiply what we put on top, x squared, times what we're dividing by, or the divisor. And so we can see that math being done right here. Use a little bit of distributive property. You can use the table method, the one that we've been learning in Lesson 2 and reversing in Lesson 3. So we then subtract, and so we get down here to basically our first part where we're about to bring down. So we multiply and we get x cubed plus 3x squared. And so x cubed plus 3x squared is written here, and we're subtracting the entire quantity. And so you have to think about it this way, and you have to think about distributing the negative sign and then combining like terms, and you're going to be left with 2x squared. So you have 2x squared, and you bring down the 7x, and we repeat. We divided x cubed by x, got x squared, multiplied them, got this expression, subtracted that expression from our function here, got 2x squared, brought down the 7x. We're here at step 5. Let's repeat the process. 2x squared divided by x. the biggest term that's left, right, the term with the highest degree, divided by x over here, 2x squared divided by x. Well, we have it over here, so let's take a look. 2x squared divided by x is equal to 2x. And so you see that 2x goes here, and then we multiply. And so we're multiplying 2x times x plus 3. And you see that here in step 2, after we repeated. Right? And now we're going to have to distribute the 2x to the x and the plus 3. This is the expression you get. We're subtracting that entire expression. That is a key function here. We're subtracting the entire thing. And that's what leaves us with x plus 3. Now, x plus 3 divided by x plus 3 is 1. 1 times x plus 3 is x plus 3, and now we have a subtraction problem here. That leaves us with no remainder, which is really nice. So, this is polynomial long division. I hope that you can see how it mimics regular division.